All right, back with part 2. Here we've got a function, and this time it's the bottom is called f at x. So I'm going to go the other way. I'll just call this, first of all, we want to graph y equals x squared minus 4, which happens to be a parabola. All right, down 4. So let's do that. Set that up. I'm going to try and use the same scale as I did before. There we go. So the blue function will be our bottom function, which is a parabola back down 4, and then the basic parabola shape. It's not stretched over 1 up 1, over 1 up 3, over 1 up 5, something like that. Same thing on the other side. There's our basic parabola. Move down 4. Now this isn't the function that we want to graph. We want to graph, it's reciprocal. So this is y equals x squared minus 4. And so now how does this go? Well, I go through my recipe, and as we get used to this, we're getting better and better at it. First thing is, let's find the asymptotes. The asymptotes happen where the bottom is 0, right? So there's a spot there and a spot there. There's going to be actually 2 asymptotes here. One there and one there. The next thing I'd look for are the stationary points. Remember, the stationary points happen when y is 1. Also on this side. It's kind of hard. It's a little bit squished. I realize that, but we'll get the idea. Or -1, right? This is when y equals 1. Here's when y equals -1, right there and right there. Now, how does the rest go? Well, the rest of the things just confirm the things that we're supposed to understand. Let's think about this section first. This graph is increasing. The red one is decreasing, right? When the blue one is close to 0, the red one is far from 0. When the blue one is far from 0, the red one is close to 0. So we can see this piece is going to be like that, right? Both are positive at the same time. When one is increasing, the other one is decreasing, and so on. Now, what's the rest of this going to look like? Well, there's more than just the 2 pieces here, isn't there? In this case, let's go to the middle piece. The middle piece is interesting. When the blue one is close to 0, and this is kind of hard to see. Maybe I'll zoom in a little bit further here. The blue one is getting close to 0. The red one's getting far from 0. So blue one's getting close to 0. Red one's getting far from 0. Now, not up here, because remember, both of them have the same sign. Where blue is negative, red is negative. So this is going to actually go down this way through this point. Similarly, here, when the blue one is getting close to 0, the red one is far from 0. And I get this sort of upside down parabola shape. Notice it doesn't go through 0, 0 because it stays negative, right? So it stays negative. So how far up does it go? Like, does it wobble or something like that in there? Well, take a specific point. That specific point, -4, it gets flipped reciprocal to -1/4, right there. That's the point 0, -1/4, right? I take -4 and flip it, and in fact, that's going to give me that middle piece. Look what happens here. We see that when the blue one's negative, the red one's negative. When the blue one is decreasing, the red one is increasing. When the red one is decreasing, the blue one is increasing. And all these things go together to tell the same story. Sometimes we don't need all of them to get the entire graph. The last piece, let's do it quickly. When blue is close to 0, red is far from 0. When blue is far from 0, red is close to 0. And it has to go through the stationary points. And then we've got it. This is the graph. F at x equals 1 over 2x squared minus 4. And the whole thing is, again, we graph the bottom and then think about what the reciprocal function looks like. I got one more left, And this one's a little bit of a strange one. There we go. Bit of a strange one. Can I fit it on? Okay, I got to zoom back out a little bit. Draw my scale on there. I'm going to use the same scale, even though we'll see that was kind of a bad idea here. But I'm still going to use the same scale because why wouldn't we? Well, the bottom, I'll call the bottom y equals x. Oops, goofed it. X plus 2 squared plus 3. So basic parabola shape moved left 2 and up 3. All right, left 2 and up 3. Left 2 and up 3 right there. And then basic shape, not stretched, so I get the grade 10 parabola that looks like this. I guess just to be consistent, I should have put that in blue, but we get the idea. This is y equals x plus 2 squared plus 3. And now we want to graph its reciprocal. So how do we graph the reciprocal is we started by wherever the blue graph, or the black graph in this case, is 0, I'm going to have its reciprocal is undefined, or I'll get an asymptote. Now look here, this black graph, where is it 0? Well, it never crosses the x-axis. It's never 0. So there's going to be no vertical asymptotes. That kind of makes sense. When I look at this graph, what are some x values that aren't allowed? Well, it's when the bottom can't be 0. I can't divide by 0, but this thing's always positive, or 0, and then I add 3 to it, it's never going to be 0. There's not going to be any vertical asymptotes. I didn't mean to cross that out. I meant to underline that. Okay, so fine. So I can't use that first one. What was the rest? Well, stationary points. The stationary points happen when y is equal to 1, like over here, or negative 1. Well, where's y equal to 1 or negative 1? It's not. There's no stationary points at all. All right, well, let's get our recipe. Our recipe's kind of falling short here. So that didn't work. What about this one? If f is positive, then the reciprocal function is positive. Well, this black function is always positive, so it means the reciprocal one, the one I'm gonna write in red, is also always going to be positive. So that means it's never going to cross the y-axis. It's never going to be below the x-axis, rather. That still didn't help. Graphs didn't touch. This is important. When f at x is increasing, the reciprocal function is decreasing. Okay, so when the bottom is increasing, the reciprocal is decreasing. So I know that the red function should be going downhill after x equals minus 2. So it's going downhill on this side, and the same thing, the opposite here. It's going uphill here because this one's going downhill. I still don't see the cutoff spot, though. Well, let's keep going. When f at x is close to 0, its reciprocal is far from 0. This one's never close to 0, so it means the red one's never going to be far from 0. But let's think of it the other way. When the bottom is far from 0, the red one is close to 0. So see how this one goes up and up and up and up and up? Well, that means this one must be low. When this one goes up and up and up, this one must be close to 0. Well, how does this work? Well, we also said that it increases when this one is decreasing. So it's going to increase to some spot, and then this one starts increasing, so this one's going to start decreasing. Well, till where? Well, this has an output of 3, so that means its reciprocal is 1 over 3. So that means if I zoom in here, view, zoom in, get nice and close, this was 3. Its reciprocal is 1/3. And this is very hard to see, but the idea here, and I'm going to have to fix this up a little bit, is this one increases to get to that maximum spot and then decreases after that because this one's increasing, this one's decreasing. So this is actually a very strange little graph where it's got a little bump in it, like this. And in fact, if I wanted to, put that point there, that's the point -2 1/3. I could get this point, right? Because its y-intercept is when x is 0. When x is 0, y is, or supposed to be, right there is, what's that, 2, 4, 6, 7, is 7. That's, its reciprocal is 7 flipped, or 1/7. That's supposed to be 1/7. And this is what I call the pimple graph. Because the idea of it's almost always 0, and then it has a little bump in it, like a pimple. That's it, pimple graph. All right, on to the last example. That's a weird one. Usually we at least have 1 or 2 vertical asymptotes to have fun with. All right, now which one are we talking about? Refer to your graph from example 2b, fill in the chart. So the x-intercepts of this one were 2 and -2. And this one had vertical asymptotes then of x equals 2 and x equals -2. When is the function value greater than 0? Well, it was greater than 0 in this piece and this piece, right? X is greater than 2, x is less than -2. When was this one positive? Same thing. X is greater than 2, x is less than -2. When was the function value negative? Well, this graph dipped below the x-axis in between 2 and -2. And that was the same thing over here. When was the function increasing? Well, this function p at x was increasing after the vertex, which was x equals 0. So function is increasing for x is greater than 0. When was this function increasing? Well, this one was increasing when this one was decreasing. So it's almost, you have to do one with the other. This function decreases for x less than 0, and they kind of switch, don't they? This one was increasing for x is less than 0. Let's have a look at that. X is less than 0. Yeah, going uphill, uphill. Then at that cutoff point, x equals 0, going downhill. Absolutely. The function value y equals 1 had an, I guess this is an x value we're interested in. Well, when is the y value equal to 1? All I'd have to do is set this thing equal to 1 and solve that little tiny equation. Add 4 to both sides. Square root is positive and negative square root of 5. Does this look like the positive and negative square root of 5? Well, what's the decimal value of that? Decimal value of that is around, well, I don't have it written down, but I suppose we could use a calculator. Calculator. Get my calculator out here. Guess I could use my graphing calculator, but oh well. Calculator. 5 square root. No, not the square root. Oh, there's a square root. Clear. Got it. 2.23. Does that look like 2.23 on the graph? 2.23? Negative 2.23? Sure it did. Dandy. And what's funny is we know that this one's the same thing. So when is this equal to 1? And we see what's going on algebraically. I multiply by that, and I get the exact same equation, don't I? Same. What about when the function value is equal to -1? Add 4 to both sides. It's going to be the positive and negative square root of 3, which is about positive and negative 1.7-ish. And did I get my stationary points at positive and negative 1.7-ish? You bet. Dandy. And if I do the same thing over here, cross multiply, I get the same thing. Okay. A little bit of analysis there to make us think about this relationship between functions and the reciprocals. There's some from the homework there. Notice that number 15, you just pick a couple of those, and this is a bonus question, not a bonus question, but an extra one. I want you to try that, and because that's good, clean fun, and then the FAQ is there as well. All right, that's it.